Every bar of chocolate begins somewhere far from the factory floor. It begins on a tree, in a climate no machine can replicate, and it takes a journey of thousands of kilometers, dozens of processes, and hundreds of decisions before it reaches your hand. What follows is the story of how a bitter tropical seed becomes one of the most beloved foods in the world. From the jungle canopy to the supermarket shelf, from a single pod to a perfectly wrapped bar, this is chocolate, from bean to bar. It begins here, under the dense canopy of a cacao tree, in a thin belt of land 20 degrees north and south of the equator. Pods the size of a small rugby ball grow directly from the trunk. There's no temperate climate alternative. Cacao demands humidity, warmth, shade, and patience. A single tree can take 5 years to bear its first fruit. Each ripe pod holds roughly 40 seeds, suspended in a sweet, sticky white pulp. Those seeds are the raw material for every chocolate bar on Earth. The fruit is harvested by hand, one pod at a time, with a machete or a hooked pole. A single tree might yield 30 pods a year. The pods are split open and the seeds, still coated in pulp, are scooped into wooden crates or piled under banana leaves. What happens next is invisible and critical. For up to a week, the pulp ferments. Wild yeasts feed on the sugars, producing alcohol. Bacteria turn the alcohol into acids. The heat of fermentation, climbing past 50 degrees Celsius, kills the seed inside, and complex chemical precursors of chocolate flavor begin to form. Without this step, the beans would taste only of bitter astringency. After fermentation, they are spread out on wide wooden platforms to dry in the sun, raked and turned daily, until their moisture drops below 7%. Only then are they bagged into burlap sacks, graded, and shipped to the factory. The sacks arrive at the factory by the shipping container. West Africa, South America, Indonesia. Each region brings a different flavor profile, and most finished bars are blends, drawn from several origins at once. Every incoming batch is sampled. Lab technicians cut beans in half, judging their color and their internal structure. They roast small test batches, grind them, taste them. They test for moisture, for mold, for free fatty acids, for flavor potential. A single bad sack can taint an entire production run. Only once a batch is approved do the sacks move onto the line. They are slit open, tipped into steel hoppers, and vacuum cleaned to pull out dust, string, stones, and the occasional shard of metal. From the hopper, the beans are elevated on enclosed conveyors to the top of the factory, and the industrial process begins. Roasting is where chocolate flavor is born. The beans travel into a rotating drum roaster, heated by gas or direct hot air to around 130 degrees Celsius. For 30 to 50 minutes, they are tumbled through the heat. The drum never stops turning. Moisture is driven out. The shells darken and loosen, and inside each bean, the Maillard reaction begins. The same chemistry that gives coffee, seared meat, and toasted bread their complex, savory, roasted notes. Hundreds of volatile aromatic compounds form, many of which exist nowhere else in nature. This is the step that transforms a fermented seed into something you would recognize as chocolate. The roaster operator watches temperature curves, sample trays, and the smell of the exhaust air like a hawk. A few minutes too long, and the beans turn bitter and acrid. A few minutes too short, and the flavor stays flat and grassy. When the roast hits its target, The beans are dropped into a cooling tray, where rapid airflow halts the reaction within seconds. After roasting, each bean is little more than a dark kernel, loosely wrapped in a brittle, papery shell. That shell has to come off, and at factory scale, that is the job of a machine called a winnower. The beans pass between toothed rollers, which craggle but do not crush, every single one. The broken pieces then fall through a vertical column, where a column of air blows upward at a carefully calibrated speed. The shells, being light, are lifted away. The dense, oily heart of the bean, called the nib, falls through, collected below. What remains is nothing but roasted, cracked cocoa, ready to be ground. It is the nib, and the nib alone, that will become chocolate. The nibs are fed into a grinder. Depending on the factory, it might be a toothed mill, a stone roller, or a ball mill. But the principle is the same. Apply heat and friction, and the structure of the nib collapses. More than half of the nib by weight is cocoa butter. As the nibs are crushed, the butter locked inside each cell begins to melt from the friction alone, and within minutes, the entire mass has liquefied. What emerges is a thick, glossy brown paste. This paste is called cocoa liquor, or cocoa mass. Despite the name, it contains no alcohol. It is pure chocolate in its rawest form, 53% cocoa butter, 47% cocoa solids, and nothing else. No sugar, no milk, no additives. From here, it will take one of two paths. Some of it will be pressed further to separate the butter from the solids, producing pure cocoa butter and cocoa powder. The rest will continue down the line, headed for the bar. Now comes the step that separates good chocolate from great. The cocoa mass is transferred to a machine called a conch, named after the seashell shape of the original, invented by Rudolf Lindt in 1879. Into the conch go the recipe's remaining ingredients: sugar, extra cocoa butter, perhaps vanilla, and for a milk chocolate, dried milk powder. The conch begins to turn. For anywhere between 12 hours and 3 full days, heavy rollers or paddles shear the mixture back and forth, against a warm steel bed. Two things happen, slowly in parallel. First, the solid particles, the sugar crystals, the cocoa solids, the milk powder, are ground progressively finer, down to less than 20 microns across. Below that size, the human tongue cannot detect them, and the chocolate feels silky rather than gritty. Second, because the conche runs warm and open to the air, unwanted volatile compounds, acetic acid, other off flavors left over from fermentation, evaporate off. What enters the conche as a thick, rough paste emerges as silken, aromatic, finished chocolate. Many chocolate makers argue this is the step that matters most of all. Chocolate has a secret that almost no other food has. The cocoa butter inside it can crystallize in 6 different forms, depending on exactly how it is cooled, and only one of those 6 forms actually tastes and behaves the way chocolate should. That one is called Form 5, or Beta V. Tempering is the controlled dance of heating and cooling that forces every molecule of cocoa butter to line up in that single correct structure. The chocolate is first warmed to around 50 degrees Celsius, melting any existing crystals completely. Then, it is cooled to around 27 degrees, during which many crystal forms begin to grow. Then, critically, it is gently warmed again to 31 degrees. At that final temperature, the lower quality crystals, forms 1 through 4, simply melt away, while the stable form 5 crystals survive and multiply through the entire mass. Done correctly, the result is chocolate that snaps cleanly when broken, that shines like polished glass, that releases its flavor cleanly on the palate, and that melts at exactly body temperature. No lower, no higher. Done incorrectly, it turns dull, crumbles under pressure, and within days blooms with streaks and patches of white as the unstable crystals migrate to the surface. This is why every serious chocolate factory invests in tempering machines that hold temperature to within 1/10 of a degree. Tempered chocolate now flows into molds, long polycarbonate trays, each one precision cut with the shape of the finished bar. Rectangles, squares, domed segments, raised logos glide below a row of depositor nozzles. Each nozzle opens for a fraction of a second, timed to the speed of the conveyor, dosing exactly the right weight of chocolate into every single cavity. Too much, and the factory wastes product. Too little, and the bar fails its weight check. A single depositor line can fill 6 or 8 bars per second. The filled molds then pass onto a vibrating table. The table shakes the molds at hundreds of cycles per minute, with just enough force to settle the chocolate into every sharp corner of the mold and to lift any trapped air bubbles up through the liquid, where they pop at the surface. The result is a perfectly filled, perfectly smooth bar, still liquid, still warm, and ready for the next stage. For bars that carry inclusions, whole hazelnuts, roasted almonds, freeze-dried raspberries, crisped rice, caramel pieces, this is the moment they are added. Each inclusion sits in its own overhead hopper, weighed and dosed by gravity onto the still liquid chocolate in each cavity. Timing matters. Too early, and the inclusions sink to the bottom. Too late, and the chocolate has already skinned over. Once the inclusions are placed, a second, thinner curtain of tempered chocolate is deposited over the top, sealing everything inside. The bar now has internal structure: chocolate below, filling in the middle, chocolate above. The same station can also inject liquid centers, caramel, praline, ganache, through fine hollow needles, turning a solid bar into a filled chocolate. The filled molds now enter a cooling tunnel, a long enclosed conveyor that may stretch 15 or 20 meters. Over the next 20 minutes, the molds travel through a sequence of carefully controlled zones, each one a degree or two colder than the last. The gradual cool is absolutely critical. Shock cooling would ruin the hard-won tempering, causing the wrong crystal forms to take hold and the chocolate to bloom within days. As the bars cool, a remarkable thing happens. The chocolate contracts by roughly 2% in volume, just enough to pull itself away from the polished walls of each cavity. The bar becomes a solid, glossy slab, sitting in a mold that no longer grips it. When the molds emerge at the far end of the tunnel, every bar is ready to be freed. At the end of the tunnel, the molds are flipped upside down and tapped sharply against a metal rail. The bars drop out cleanly, glossy side up, onto a receiving conveyor. This is the first time in the entire process that the finished bar sees open air. It is also the first time it can be inspected. An overhead camera system photographs every single bar as it passes, comparing it pixel by pixel to a reference image of the perfect bar. Cracks, missing corners, fingerprints, streaks, sugar bloom, misplaced inclusions. Anything that falls outside tolerance triggers a puff of compressed air that ejects the bar sideways into a reject bin, usually within half a second. The rejected bars are not thrown away. They are remelted and fed back into the line. The bars that pass carry on. The finished bars, Now meet their wrappers. A reel of thin aluminum foil, or a metallized film, unwinds from above the line at the speed of several meters per second. Each bar is driven beneath it, and a series of folding heads bend the foil neatly around the bar, corners tucked, edges pressed closed. A second machine applies the outer paper sleeve or printed wrap. The label, the logo, the barcode, the nutritional panel, the branding that a consumer will ever actually see. Some lines use flow wrap packaging, sealing each bar inside a heat-fused plastic film in a continuous motion. The wrapped bars travel on, now visually indistinguishable from the final product on the shelf. A downstream counter machine collects them in groups of 12 or 24 and slides them, in precisely aligned rows, into printed outer cartons. Those cartons are taped closed, labeled, stacked by robotic arm onto wooden pallets, wrapped in clear stretch film, and moved by forklift to the dispatch bay. Within days, the bar that began as a seed on a tree 5,000 kilometers away will be loaded into a truck, driven to a distribution center, transferred to another truck, and placed on a shelf, waiting to be chosen. From pod to bean to paste to bar. From fermentation to roast to conch to temper to mold to shelf. Every bar of chocolate you have ever eaten took this journey. A journey of months, of thousands of kilometers, of dozens of specialized machines, of hundreds of careful human decisions. The next time you break a square off a bar and let it melt on your tongue, remember, it began on a tree. Thank you for watching. If you enjoyed this, subscribe for the next one.